Okay, welcome everybody. Today we're going to talk about significant figures, okay? This has to do with the precision of the tools that you're measuring with. Some things measure to the 10th of a milliliter, some things measure to the 100th of a milliliter, some things measure to the 1,000th. We can't report answers to the 1,000th if our piece of equipment is only precise to the 10th of a milliliter. Okay, so we can't, just have a bunch of numbers there that give us an idea that there's more precision than there actually is. Okay, all right, so significant figures. They are also known as Sig Figs. Okay, that's the abbreviation for them, Sig Figs. Okay, so again, we're talking about the number of digits in a reported answer because some tools are more precise than others. Okay, more precise tools are going to give measurements with more significant figures, more sig figs. Okay, it would not be accurate to report a measurement with more significant figures, more sig figs, than the tool's scale divisions. And remember, when we're measuring, we look at the scale division and then we estimate one more place value. Well, if I have a 10th marked and I estimate a 100th place, I can't record a measurement out to the 1,000th or 10,000th place. Okay? It doesn't work that way. I can't have 9 decimal numbers if my equipment only goes to 1 and I estimate another. Okay, so how do you look at a measurement and determine how many significant figures it has? What are the rules for sig figs? This is a big idea. Okay, so you need to make sure that you kind of pay attention here. All right, first off, anytime I look at a measurement, any non-zero numbers, so that's anything 1 through 9, any of those digits are going to be considered significant figures. It's easy, right? All the rest of these rules have to do with zeros. That's where the question lies. Okay, so zeros we refer to as sandwich zeros. So if I have the number 101, see that 0 in the middle, like the peanut butter in the sandwich between the ones? That counts as a significant figure. The ones, of course, count because all non-zero numbers count. That sandwich zero counts. Okay? All right. Leading zeros are never significant. So what is a leading zero? Those are zeros that are before any digits in a number. So for example, if I had this number, those zeros before the 1, the zeros leading up to the 1, do not count as significant figures. So I'm going to put X's over those. They don't count. The 1 counts because it's a non-zero digit. Now, are they important? Yes. The answer is yes, they're important. They're placeholders. We need them. I mean, the number 1 is way different than the number 0.0001. But do they count as significant figures when we're looking at the precision of a tool? No. Okay? So remember, significant and important don't necessarily mean the same thing. Okay, so leading zeros, never significant. Trailing zeros are significant if a decimal is present. Okay, so first off, what is a trailing zero? Those are zeros at the end of a number after non-zero digits. So if I write down the number 1,000, those zeros at the end of that number are trailing zeros. Now if I look at that number, it could be rounded. I mean, it could really be 999 and I just said about 1,000, right? There's nothing there that tells me that that's a really precise measurement. So those zeros at the end don't count as significant figures. Yes, they're placeholders. Yes, they're important, but they don't count as significant figures. The 1 at the beginning counts as a sig fig because it's a non-zero digit. So this reported measurement, 1,000, would only have 1 significant figure. Now, if I rewrite that number, you see the decimal and another 0. That decimal all of a sudden made all those zeros at the end of the number before or after the decimal significant. So now all of these count as significant figures. They all get a check mark. So this recorded measurement would have 5 significant figures. That's not a rounded number. It's 1,000.0. It's right on the dot. Okay? So again, to get the point across, here's another number. So let's think about the rules here. I know the 1 is going to be a significant figure, okay? I know that the leading zeros before the 1 do not count as significant figures. Yes, they're placeholders. Yes, they're important, but they're not considered significant figures. The zeros after, however, are going to count as significant figures. They're at the end of the number, and that decimal right there makes any zeros at the end of a number significant. So if it has a decimal, those trailing zeros are significant, okay? Now, we only count significant figures when we're looking at measurements or calculations. When we're dealing with constants, for example, 1 mile is equal to 5,280 feet, we're not going to count significant figures with those, okay? They're just accepted values. We don't worry about their significant figures, okay? Why do we worry about this? Well, when you do math with measurements, such as in the lab, I had you guys take the average number of, the average height of a stack of pennies and divide it by the number of pennies to get the average thickness of 1 penny. So for example, if I had a height of 1.45 centimeters and that was 9 pennies, the average thickness of 1 penny is 0.16 and then a whole bunch of ones, repeating ones, okay? Well, my little ruler that I got from the dollar store doesn't measure to the 1/1,000th place, okay? That is at the dollar store. It's not that precise. It has markings, major scale divisions, every 1 centimeter. That's where the numbers are. And then it has unlabeled lines in between representing 1/10 of a centimeter. So I have markings every 1/10 of a centimeter. I'm going to estimate one more value in my measurement, which is why my measured value had 2 decimal places. That being said, I can't keep 9 decimal places in my number. That reflects a precision that my tool just doesn't have. So when we get numbers like this and we do math, sometimes we have to round. So I'm just going to flip over the notes. Okay. After calculations, values may need to be rounded to report the answer with the correct number of Sig Figs. That way we're reporting our answer with the correct amount of precision that accurately reflects the precision of the tool that I'm using. Okay? Now, you guys have been rounding since elementary school, okay? The rule is you look at the next number, the one that you're not really keeping, in order to round the last number that you are keeping. And if that next number is between 0 and 4, you keep your last number the same. If that next number is between 5 and 9, then you raise it by 1, okay? And again, we'll be practicing that more and more. Okay, now when we're doing math, there are different rules for adding and subtracting than there are for multiplying and dividing, okay? So let's talk about adding and subtracting rules. When we're adding and subtracting, answers must be reported to the fewest, the smallest place value as the least precise value in the problem. Okay, least precise value in the problem. It seems really complicated. It's not that bad. So let's say I'm adding these 3 values right here, okay? If I look at the precision of this number right here, 608, the most precise part of it is the 8, the ones place, okay? The number 7 is again in the ones place. The number 0.05 goes all the way out to the hundreds place. Which of them was the least precise value? It's going to be the ones that had the number in the ones place. Okay, they are the least precise. Which means when I'm reporting my answer, I only get to report my answer to the ones place. I'm not going to have decimal numbers there. Okay, so if I go ahead and add those up, 608 plus 7 plus 0.05 is 615.05. Now, what did I say I had to do? I could only report my answer to the ones place. So I'm going to keep 615. I'm I'm going to look at the next number to round. The next number is a 0. So what that means is I'm going to keep the number 615 the same. I'm not going to raise that up by 1. Okay? So the answer here is going to be 615. Let's look at the next one. When I look at this value here, 4,907, the most precise value is in the ones place. That's where my last significant figure is. Now if I look at the number 2,500, yeah, it goes out to the ones place, but none of those zeros count as significant figures. So really the most precise part of that number is the last significant figure, that 5, and it's sitting in the hundreds place, which means that it is the least precise. Whatever piece of equipment this was, it only measured into the hundreds. It didn't go all the way down to 1. So whatever answer I get has to reflect the precision of my least precise tool. So this one is going to be rounded to the hundreds place. So I'm going to go ahead and add that in the calculator. 7,407. Now what I said I had to do was round this to the hundreds place. So I'm going to keep the 7 and the 4. Next number is 0, so that 4 stays the same. But I can't just put 74, because I added numbers that were pretty big, and I got a number that was not close to 74. Instead, I'm going to use insignificant zeros as placeholders and bring that place value closer to my calculated answer. So my answer is going to be 7,400. Okay? Again, that has the same amount of precision as my least precise number that I added. Okay, for this decimal number, try it. Take a second, pause, try it. Think about it for a second. Once you get your answer, look at the precision of the numbers that you added together. This first value, 0.5, has a number in the tenths place. This value over here has a number in the 10,000ths place. This is a lot more precise. This is my least precise value. What does that mean? That means my reported answer can only be reported using a number in the tenths place. I can't go past that. So when you add those together, you get a long number, but you need to round it to 0.7. Okay. Now multiplying and dividing is a little bit different. Okay, when we're multiplying and dividing, it's not based on the place value. Answers must be reported using the smallest number of total Sig Figs of any value in the problem. So it's a little bit different. When you're multiplying and dividing, you're not looking at place value and where the numbers are. You're just looking at how many significant figures you have. So for example, if I have the number 0.082, those leading zeros don't count, but the 8 and the 2 do. So I have 2 Sig Figs in this value. If I look at this number, those are all non-zero numbers, so they all count as significant figures. I have 4 significant figures in this value. Which of those is the smallest number? 2. So when I do this calculation, I'm going to be allowed to keep 2 significant figures in my answer. So if I go ahead and multiply it, I get this number here with 6 decimal digits. I'm going to be allowed to keep 2. So I'm going to keep 0.7, 7, and then look at the next number to round. The next number is a 6, which means that my last number that I'm keeping has to go up by 1. So my answer to this one is actually going to be 0.78. Try it for the next one. Look at the number of significant figures, figure out which one has the fewest, do the math, and round your answer. If you look at this first value, the 2 and the 5 count as significant figures, but because there's no decimal present, the zeros do not. If I look at this value, no zeros, no problem, all 3 of those count as significant figures. Now I have 2 Sig Figs here and 3 Sig Figs here, which is the fewest? 2. So when I do this calculation, divided by, I get this number in my calculator. I'm allowed to keep two significant figures. So I'm going to keep the 4 and the 0, and look at the next number to round. It's 7. So 0 has to be raised by 1. It's going to go up to 1. Now if I put 41 here, is that close to my answer? No. My number was 400 something. I'm going to need a 0 as a placeholder, okay? The reported answer here should be 410. Again, that is rounded to reflect the precision of my tool. It has two significant figures. That 0 as a placeholder doesn't count as a significant figure. I hope that helps.